I'm going to post a new link on Classroom, but it should be good. So
Okay.
hold on. Go to the link.
Let me try it once you send it. I'll let you know. Hey,
All right, try that.
how's your hotel room?
Fine. I'm in here with a teacher from Argyle.
Oh.
Mm-hmm. Hold on, I'm typing. YouTube/GP 6K2 Y. Is that working for you?
Hold on. Let me.
All right. I had to send out a new link. Come on, children. Those that aren't watching the football game. Come on. Is your dad watching the football game?
I have to hang up with you now because it's echoing.
Oh, okay. Bye.
Bye.
Usually Gracie's in the review videos with me.
Oh, is she?
Yeah. She was like, can I just go to Austin with you? No, you can't just go to Austin with me. Hey, hold on just a sec. I got to get up and get some stuff.
Oh.
Okay. Hi, children. All right. Say hola. So I know the, 5 of you that are on here. Hey, Scarlett. Scarlett, you're not watching the football game? What? I used to hate Sundays growing up because we had the one TV, and this is all, it was football Sunday in my house. Football Sunday, that was it. If you don't like football, too bad, go outside or sit there and learn to like it. Oh, horrible. Horrible, horrible stuff. All right. This shouldn't be too long, only because there's not a whole lot. And also there's just not a lot of y'all on here to ask questions. All right. So. Anyone know what the movie is? Come on, guys. What's the movie? All right, let me get this. Okay, and all righty. Back to the Future. Good job, Scarlett. All right. Main 3 Punnett square ideas that y'all need to be able to be comfortable with: codominance, incomplete dominance, and sex-linked. So codominance and incomplete, they're going to look the same. It's going to be, how does the result come out? Remember what the prefix co means, with or together. So they're going to both the alleles, whatever they express, are going to show up together at the same time. So Dalmatians, zebras, dairy cows, black and white speckled chickens, roan-colored horses, and your blood type can be codominants because blood allele A and blood allele B are both dominant. So if you get AB, then you're actually expressing both proteins on the surface of your blood at the same time. Incomplete dominance still looks the same, but the difference is think ink for pink, because it ends up being a nice blend of the two alleles rather than an expression of either of them. So you won't see either parent in an incomplete dominant offspring. So again, your example, like black and white for the codominants, or blood AB would be an example, versus incomplete. That's where we talked about things like the pink snapdragons, or things like curly hair or wavy hair. Wavy hair, nice little incomplete. All right. And then your sex linked, you got to keep in mind, we're only concerned with what's carried on the X chromosome, not the Y. And if you are homozygous recessive as a female, that's the only way you can express it. You have a 33% chance as a female to get a sex-linked trait. But males, since they only have the one X, they have a 50% chance. That's why you have more males showing up with sex-linked traits more often, such as color blindness, hemophilia, Duchenne muscular dystrophy, night blindness, things like that. Okay, so you need to be able to do a Punnett square for either one of these. Okay, and be able to give me the genotypic and phenotypic ratios. So let me just give you a quick example of each. So a hetero roan horse crosses with a hetero roan horse. So the fact that if that's all I gave you, you'd have to just remember the example of roan horses. But more than likely in the problem, I'm going to give you a little bit more of a leading thing. And I would say if both of them are expressed at the same time, or it's an example that you should already have known, like Dalmatian or dairy cow. So you just do the Punnett square like you always would. And when you end up with the hetero to hetero, you get a 3 to a 1 for phenotype. So you get 3 dominant, 1 recessive, or you get a 1 homozygous, 2 hetero, and 1 recessive. So what would end up happening as far as how does this get expressed, that homozygous dominant would end up showing just the red hair. That hetero would end up being the roan horse, which is red and silver. And this recessive would end up being the silver showing up. Okay. Now, the Punnett square for an incomplete would look the exact same. It's just you wouldn't see either of those colors show up in the offspring. It would be the nice blend. So that's red flower mixed with the white flower mixed pink flower. But then also understand what happens if you take pink. So let's do an incomplete dominance. Okay, if you take pink crossed with red snapdragon. So pink is heterozygous, while red is an actual dominant. So I'd be crossing a hetero with a homozygous dominant. If that were to happen, then I'm going to get a 50-50% chance. I'd get 50% homozygous dominant, and I'd get 50% hetero. So in this case, you'd have half of them still looking red and half of them looking pink. If you took 2 pinks and mixed them, you'd get red, pink, and white. So you need to be able to just read your offspring. And remember when you're doing the Punnett squares, for phenotype, you just need to see how many have the dominant trait and would express it, how many would have the recessive. But since we're talking non-Mendelian, that hetero doesn't follow true dominant. It's going to either be incomplete or codominance. So you just need to look at the examples and look at your notes to be able to see which ones fall under the codominant and which ones fall under incomplete dominance. Okay. For sex-linked, remember, always just keep the allele with the sex chromosome itself, with the X. Don't accidentally, pull them off or anything, because you got to always keep it with the chromosome so you can identify if it's a male being affected or if it's a female being affected. So if I had a carrier for sex-linked trait, female, mates with a recessive male who has the trait. Remember, if the mom has it, the sons are automatically going to have it. There's no way around it. If the dad has it, then there's a high probability that the daughters will have it, but not a guarantee. All right, so if you have a mom who simply is carrying it, so she has a recessive, but a dad who has the trait, when you cross them, you have daughters who have a 50% chance of being a carrier or 50% chance of having it. So that's how you state that. 50% chance of carrying, 50% chance of having. And then sons, same thing, 50% chance of being normal, 50% chance of having the trait. Okay? You as a female can only express it if you are homozygous recessive, just like any other recessive trait. It's just unique because it's not autosomal. It's carried on your sex chromosomes instead. Okay? Because there is a difference. Things that are autosomal on 1 through 22 that evenly affect males and females. And then there's a difference with it being sex-linked because those affect males more than they do females. Question so far? Question. Monster under my bed. Nope. I've got a new band that I'm listening to. Gracie, I sent you the link. You're supposed to look them up because I got tickets to go see them during spring break. And I'll take Daddy, but if you'd rather go, then maybe I can take you, because the reality is I will be the oldest person in the group there because this kid is like 22 years old. So I'll be surrounded by like 17-year-olds and 20-year-olds at this concert, but what else? All right, Scarlett, you got any questions for me? Because as far as I know, you're the only one on here. Not really. There's a couple of you, but you're the only one that talked so far. Okay, besides doing Punnett squares, here's the thing, guys. It's great if you can do them. Yay, thank you for being an active learner. But you still have to know the vocab. Like, you still need to be able to describe what codominance means. The fact that if something is codominant, then both alleles are being expressed at the same time. Okay? If it's incomplete dominant, then neither one gets to trump the other. So you get what's known as a blend of the phenotypes. Okay? Besides the Punnett squares, then we moved into being able to know things like epistasis and know what the word epi means. Prefix word epi, which means on top of or upon. So an epistatic condition means that this is a trait that you inherit that covers up another trait. The example that I gave you in class was the yellow labs. Yellow and white labs have this condition. Genetically, they're black or brown. But because they inherited this other gene, it covers up their color, knocks it out, and you get yellow or white labs. For us, the same thing happens, and it's called albinism. So you need to know what epistasis means and know that example, right? From epistasis, then we moved into linkage maps. So we need to practice linkage maps. And then also pedigrees and karyotypes, okay? All righty. You're fine. When it comes to linkage maps, oh yeah, I get to make some up on my top of my head. Oh,
Hello.
this doesn't go well whenever I have to make it up
I'll call you in a second, okay?
completely off the top of my head. Let's just see. Let's see. Let's see if this adds up. I'm not sure if this is going to add up like I want it to, but we're just going to try. Okay. Alrighty, here's one. So kind of hold that there for a second. So, those people that want to watch this live later and like take a screenshot and practice it. So remember your rules. You always start with the largest one first. Also, guys, know what linkage maps mean? Like, what are we doing when we make these? We're drawing a chromosome. We're placing the genes. Those letters represent genes on the chromosome. But the reason is because genes that are close together on the same chromosome are called linked genes because it's so hard for them to get separated during crossover. So when we're studying genetics and we're looking at different organisms' genes, we're trying to see how they get inherited. If we see that the same genes seem to always get inherited together, and when we map it, if they're really close and they don't get separated very easily, we call them linked, okay? So we start with the largest gap first. Largest gap is A to B, which measures 23. Use one of the letters you already had, so I'm going to use A. If I go back up here, I see A to C is 15. Knowing that there's only 3 to place, and 15 plus 8 equals 23, that would be your linkage map. And you do need to go ahead and show me all pieces. You need to show me all of the genes written out and show me their different spacings as well. Who just texted me? Can't chat, so I'm going to text you. Hi, I've got a question. Okay. You just said you can't chat. I lied, I can chat. Okay, I've got a question about the review and the pedigree chart. It says it's dominant, but they're an unshaded generation. Like a whole generation is unshaded. That can happen. No, let me double check. Let me pull up my review real quick, which one you're looking at. Hold on. I'll come up with another linkage map while I'm thinking. On this second. All right, okay, Gracie, if you're talking about number 19, the one that on the test review I say is a dominant pedigree, and you're looking at that very last generation and how those children are all unshaded, that's because their parents are unshaded. And if it's a dominant pedigree, that means the unshaded individuals are recessive. If you're recessive, all you can give is recessive, so their children can't show up shaded, or else a dominant played in, and oh no, you've got the milkman's baby all of a sudden. Okay, double check, make sure that's the one you're thinking of. Okay, yeah, because the first one's dominant, the second one's recessive. So your tricks can help, but they're just that, they're tricks. The only thing that is a guaranteed rule for pedigrees: shaded children from unshaded parents. If you see that, that be recessive? Okay. You have shaded kids from an unshaded parent or unshaded parents. That's recessive. So your tricks, the fact that dominant should show up in every generation. Yes, that's a trick. Recessive should skip a generation. That's a trick. This is a guarantee. Your dominant and recessive tricks just help you, but they're not guarantees. You can have a recessive pedigree where it shows up in every generation because they kept marrying recessives where they kept marrying heterozygous individuals and their children kept getting that percent probability of being recessive. It can happen. Or in the pedigree on the worksheet, it's dominant because as of right now, that pedigree is only showing you children from a cross of 2 recessives. But if it kept going and showed you marriage between a dominant and their children, then you'll see dominant again in that generation. Okay. All right. Let me think of another Punnett square. Yeah, I put mine in the middle drawer because I saw your laptop bag in that top drawer. And you notice your laptop bag is the same as my backpack.
I know.
That's all we have is the Vera Bradley backpacks and bags and everything, and the wallets and the lunch boxes. All right, let me think of another linkage map real quick. You know what? I do a lot of ABCD. How about I go all kinds of crazy and do like QRST or something? Right? That's so crazy. Okay, a Q to an R. Let's say it's 12. R to a T is 5. I don't know. I'm just making it up. S to a Q is 30. And a T to an S. Okay, give me just a second. Let me. OPMN. Are you just giving me letters? Or is OPNM supposed to say something? Okay. Yeah. I'm just going to let you think on that for a second, Gracie. Okay. S, Q to an R is 12. R to a T is 5. 8. Dang it. Let me do this. Okay, let me do this. I changed this. I fixed that. And there we go. Okay. Okay, here's another one. Go ahead and try that. Linkage map. Yes, I know those are letters. Thank you, Captain Obvious. Good Lord. Okay, so Q to R. Oh, that was funny. Q to R is 12. R to T is 10. S to Q is 30. And T to S is 8. So see what you can make out of that real quick. That was funny. I think it's going to be an early night for me. I think I'm going to be tired. Alrighty. All right, see what you get from that. I'm going to kind of put it off to the side, actually, because I have more room over here. So start with your biggest gap, S to Q, and then Q to R is my next biggest. So I'm going to go ahead and put that one, which is 12. That then leaves me the remaining 18 to place. R to T is 10. And then S to T is 8. Oops. There you go. That should be your linkage map when you're done. Alrighty. Good deal. Do you need another practice on linkage map? Yes, no, yes. So linked is the two letters the closest. Yes, exactly. I mean, we could technically kind of claim multiples on there could be linked. It just means when they're on the same chromosome, like our pictures, and they're close together, that they don't get separated very often. But yes, if I'm just showing you a picture and I asked you which ones are the most linked, yeah, I'd be the ones that are the closest together, Scarlett. Andrew Fowler. Who dis? Who's Andrew Fowler? Who dis? Oh, okay. You totally threw me off. Hey, sweetie. Okay. Phew. I was like, I mean, you wanna join this too, whoever you are, random person? Okay, good deal. All right, no more linkage maps. Let me give you a couple of pedigree practices real quick. All righty. Bloop, 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 bloop. Remember, don't forget who's who. Males are SpongeBob SquarePants, square. Mrs. Puff is the circle. If it's horizontal, they are married. If it is vertical, those are their children. Beep, 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 beep. Beep, 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 beep. I am okay. All right. What do you think this is? Isn't SpongeBob's monster? Hey. She's a deformity. And I think she's only circular on her head because she wears that necklace. And I think it's probably too tight. And it's causing a deformity. But SpongeBob himself is square. So we'll use it. Yes, Scarlett, it would be recessive and it would be sex-linked. There are males being shaded. So if I asked you, if I asked you for generation and individual genotypes, it is not recessive autosomal, Gracie. Sex-linked, more males shaded. But here's the thing. In this case, so if I asked you to actually apply genotypes, so if it was the male, if this was sex-linked, then we know that the mom, for a fact, was dominant. No, for a fact she's dominant, but we have to figure out what her second letter is, and we might not be able to figure it out from this data. But daughter down here, we know is also dominant because she's not shaded. So I'm going to give her a capital A. She got that dominant A from mom. Then that means that she had to have gotten that recessive X from dad. So daughter, we know, is heterozygous. She's a carrier. That also means down here why she has one son that is shaded, one son that isn't. Because one son got the recessive A, the other son got a dominant A. So if I asked you about this individual's genotype, so generation 2, individual 3. So generation 2, individual 3. If I asked you for their genotype, you do know what it is. For a fact, you know it is an XY because it's a male. And it has to inherit the X from the mom. But the fact that they're not shaded tells you that they have to be dominant since you already determined this pedigree is for recessive, which means anybody who has a shade is recessive. So generation 2, individual 2 has to be X dominant Y. All right. Let me give you another example, another one. I love pedigrees. I think they're so much fun. I think they're like little puzzles. Don't you agree, Miss Malcolm?
Absolutely.
Pedigrees, they're so much fun. Do you want to say hi?
Hi.
Well, maybe my kids.
That's my roomie. Yeah, okay, let me give you another pedigree. Hold on. Who's winning the Super Bowl? Do we even know? Do we even care?
I just Googled.
Oh, yeah? You did?
10 to 10.
Oh, I was about, you said 10 to 10. I was about to say who's winning. Okay, all I know is it's the Kansas City Chiefs and the 49ers. Right, I think so. Only because it's all on, every single like Facebook, Instagram, whatever. You can't escape it. Good Lord. Whatever. The only thing I enjoyed about Super Bowl Sunday is my parents would go get all the crap food, and I got to eat crap food all day. Like, I know
Absolutely.
some people are going to be like, gross. I loved when my parents got crab dip. Like from the grocery store, it's like crab dip. It was the crab, but still it was crab dip and club crackers. I'd eat that like, and back in the day at Winn-Dixie, you could get M&Ms. And I want to say they were like the store's brand of M&Ms, not like real M&Ms. But they used to sell M&Ms in blue and silver in honor of Dallas Cowboys. And so my parents would always get those kind of M&Ms. And then the imitation crab dip with crackers and just like other crap. We ate crap. Oops. So I like the crap food in the halftime. Who's doing the halftime show, Scarlett? I don't even know. I saw Demi Lovato did the national anthem or something just because I saw it on the news. Oops. So, again, I would have no clue. All righty. Shakira and J-Lo. Okay. Interesting. I could almost I would be able to watch the Shakira part. I wouldn't be able to watch the J-Lo part. It's nothing against her. She's just not my kind of music. Neither of them are my kind of music, but whatever. Okay. Here's another one. Solve the puzzle. Watching the other Back to the Future 2. Back to the Future goes to the future, right? Or Back to
It's the future.
It's just, I know it's called, but is it just called Back to the Future 2 or didn't it have a name? Back to the Future. Because isn't the last one, it's Back to the Future 3, Futures Past or something?
Let's see.
That was me too. I know, right? Yeah. Okay, what do we think this one is?
Just call Back to the Future Part 2.
Okay. All right. Do we know what we think this would be? All right, so first rule to always look for. Do you have shaded coming from unshaded? Ding, ding, ding. If you do, shaded coming from unshaded, then it has to be recessive. Same thing here. Shaded coming from unshaded. So it is a recessive trait. Now your answer has to go, and you either have to tell me if it's autosomal or if it's sex-linked. So if it's sex-linked, right? If it ends up being sex-linked, look for having more males shaded than you do females having shaded. That's kind of a, helps you situation, okay? But also, here's the other thing. Scarlett, you think it's sex-linked, but look at this one. If it's sex-linked, then that means those girls have 2 affected alleles, which means their dad would have to be affected. So dad would have to be shaded if it was sex-linked. So it's not sex-linked, it's just autosomal recessive. Good old-fashioned chromosomes 1 through 22. Okay? All right, let me show you another one. So, I mean, there's only 3 options when it comes to the pedigrees that I'm testing you on. Autosomal recessive, autosomal dominant, or sex-linked recessive. We are not doing a sex-linked dominant. We're not. So stop saying sex-linked dominant, people. Yes, it's autosomal. Sorry. Okay. Whew. My circles and my squares don't really look like circles or squares, so I'm just gonna pretend like I can color, okay? Ow! All right, try that one. Whew. Okay. So if it skips a generation, it is recessive, and it doesn't necessarily mean it is sex-linked. Oh yeah, it definitely doesn't mean it's sex-linked. It can be autosomal. The shaded children coming from unshaded parents just confirms that it's recessive. That's it. Then you've got to figure out if it's autosomal or sex-linked from there. So look for the number of males versus females. If you have an abnormal number of males, then you're probably going to be at sex-linked. Then you got to look for those other 2 kind of tricks. They're not even tricks, they're rules. If it's sex-linked, then if you have a shaded mom, all of her sons have to be shaded. Okay? If it's sex-linked and you have a shaded daughter, then you have to have a shaded dad. That's only if it's sex-linked. So if those don't happen in the pedigree, it's autosomal. Okay. All right. So look at that one. Man, I thought about bringing my heating pad because my sciatic nerve acts up here and there, and I didn't.
Uh-oh.
Now I'm kind of regretting it. All right. This one is, so the thing to look at, you have it showing up in every generation. So that makes you think dominant. You do not have any unshaded, shaded situations, right? So it's not recessive. Don't worry about that one. That's just the one I couldn't quite figure out if it was a square or a circle. So, you know, whatevs. Okay. So that shaded, unshaded isn't a thing in here. So since it's showing up in every generation, this is dominant. And the only dominant one I'm going to ask you is autosomal. So autosomal dominant. Now, here's the next part of the question, though. You got to be able to tell me genotypes. So if I said generation 2, individual 3. Generation 2, individual 3. So the generations go from top to bottom. So 1, 2, 3, 4. So there's 4 generations in this picture. So I want generation 2. And then you just count from this side. 1, 2, 3. So I want the genotype of that guy. Since this is autosomal, it is not sex. You do not put the chromosomes X and Y. You just put the letters. So if I've determined this is a dominant, then that means I'm going to label all the shaded individuals with the trait with a dominant letter. That means anybody who is not shaded has to be the opposite. So they have to be recessive. So that means that this guy is homozygous recessive. Good job, Scarlett. So if it shows up in every generation, it's dominant. Yes. Here again, Scarlett, that's a trick. It's not a guarantee. The only things that are guarantees are shaded children from unshaded parents, recessive. Okay. A daughter who's recessive and has it, if it's sex-linked, dad has to have it. That's also a guarantee. If it's sex-linked and mom has it, all of her sons have to have it. That's a guarantee. The other things I say, like it skips a generation if it's recessive, It doesn't skip a generation. It's dominant. Those are tricks to help solve it once you've identified if it's dominant or recessive. That was Gracie, not Scott. Oh, sorry. Just kidding. Okay. I don't know how to read. Okay. Okay. So if it shows up in every generation, no. Like I just said. Okay. It's just a trick. When you look at a pedigree, the first thing you want to do is look for the guaranteed thing. Do you see any shaded children coming from unshaded parents? If you don't, start moving towards the dominant possibility. If you want to confirm it, just plug in some letters. So if you think it's dominant, put capital A's. See if it works out. Can they be heterozygous and potentially have recessive children? Okay. All right. Do y'all need another pedigree example? Or another linkage map? Okay, besides that and linkage maps and then being able to look at a karyotype, you have to know the vocab. What does karyotype mean? Yes, you want another pedigree. Okay. Think about what the word karyotype means. Karyotype is the picture of the chromosomes. So that's where you put all the homologous chromosomes next to each other, right? And so you go from 1 all the way down to 23. When it comes to a karyotype, you have to be able to look at whether or not it's male or female, first of all. So look at the very last chromosomes and then be able to tell me if it's healthy or unhealthy. All right, yes, I'll give you another pedigree, Gracie, and then I'm going to show y'all, or I'll just kind of jot down a karyotype because I don't really feel like drawing an entire set of karyotype picture. All right. Guys, always remember, look at your test review answers that are posted on your task sheet. Oh my God, I still need to finish the task sheet for this week. I hadn't finished it yet. Crap. Okay, I'll get that done. Along with everything else. Oh, the days are not long enough. Unless you're giving star tests, then they're too long. Okay. I'm going to give y'all messed up pedigree on. Woohoo! Only because I ran out of space. So, this is how I decided to roll. Ha ha. Ha 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 ha. Let me see. Let me see. Let me. Oh, yeah, I like this one. This is a good one. You're going to have to think of all your rules. You're going to have to really stop, right, and think about the, okay, karyotype chromosomes in a cell that will show XX or XY and Down syndrome. What was the word for 24? So, yes, karyotype chromosome, it's a picture of the chromosomes in a cell, okay, next to their homologs lined up in order, all the way down to XX or XY. And then, so yes, Down syndrome is just an example I gave you of the picture. It's actually called trisomy 21 because there's 3 of the 21st chromosome. All right, here's your next pedigree. Think about this one. All right, so first thing you should be able to notice about this one is the rule. Guaranteed. Shaded children coming from unshaded parents. Ding, 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 ding. You got that for sure. Generation 3 over here. So that has to mean it's recessive. So now you've got to decide, is it autosomal or sex-linked? Bless you.
Thank you.
Okay. Now what's funny, if you notice, I had them get married. They're related. Oh So, it was mostly because I ran out of room. Okay, so Scarlett, you're thinking it's sex linked. Here's the only thing. If it's sex linked, you have a daughter, and if she was sex linked, then we need to give her letters. So this is where you need to confirm your answer first before you finalize it. So if it was sex linked, I would do that for that girl. And I'd have to do this for this male. Right? How can this work out? Like for this girl, she has to get one from mom and she has to get one from dad. So that means that dad has, if this was the case, then that dad would have to have a lowercase a as well. So he would have to be shaded. Nope. So it can't be sex linked. It has to be autosomal. Just because all the males are shaded, or more males are shaded than females, remember, that's just a trick. It's not a rule. Just a trick. You've got to confirm. And so, yeah, there's more males, but this is not sex linked, or else, in this case, this daughter that I shaded, that father would have to be shaded if this was sex linked. Notice I didn't shade the mom, because again, if this was sex linked, that mom wouldn't have to be shaded. She could just be a dominant still and passed on her bad allele to her sons. So this is autosomal recessive. Okay, I give you uno más. Did I say that right, Gracie? Uno más. Okay. All right, let me think of this one. Good. See, your mom knows. Your mom Prende Español un poquito. Mm-hmm. What? C. Yes. All right. Last one. What be this? What be this? Come on. Type before I say it. You got it? You got it? You got it? All right, so first thing, it skipped a generation, right? Shaded from unshaded. But in this case, so it has to be recessive. We know that. Sex linked. You have a shaded daughter. You do not have a shaded dad, so it can't be sex linked. Is it another? There's no trick on this one. It is autosomal recessive. It is. Okay. All right. All right. Last thing, just confirm that y'all. Again, this is my drawing, not an actual picture. So, right, got chromosomes 1 through 22. Okay, I'm not drawing all of them. Good Lord. Anyway, so you get all the way down, and you get down to these. Okay, just looking at this. If I didn't know any better, like I'm just like, oh, what is that person doing? This kind of like this looks like it could be like Arabic letters or Farsi or something. Oh, it's funny. Okay, so they're paired up in their homologs. Keep in mind, when you see it bent like this and stuff, that doesn't mean anything. You're looking for missing pieces. You're looking for extra chromosomes. You're looking for an entire chromosome gone, that kind of thing. Okay, but if this was chromosome set number 23, What would this be, male or female? So keep in mind, they are not next to each other. They are different in size. So they cannot be confirmed as homologous chromosomes because they are X and Y. This is a male. The Y is always smaller, and they won't be next to each other because even though they're both sex chromosomes, they are technically not considered homologous. Okay, and then again, you're just looking to see if there's anything wrong with the person. So just look to see if you see extras, if you see chromosomes missing, that kind of thing. Okay, let me kind of double check some things. Ooh, let me give you, I did not give you any blood type question. I did not give you a blood type question. Let me give you a blood type real quick. And then I think we're pretty good. Okay, so keep a couple things in mind. Blood type, human blood type is an example of multiple allele because you have three versions. You can have the alleles A, B, or O. Remember, A, B are what we know as dominant, and O is a true recessive. You can see it written where it's written as an I to the allele, so I superscript A, I superscript B, or it's written as a lowercase I if it's an O, right? So be able to know phenotype versus genotype for blood. If I say you just have blood type A, all that means is you have blood type A. I still have to confirm what genotype you have. Are you homozygous or are you heterozygous? So if I said a hetero A woman has an AB child, what is the father? Ooh, you can't read my handwriting, but that's okay. If a hetero A woman has an AB child, what does the father have to be? So you don't even have to do a Punnett square to confirm this by any means. If mom has an A allele and child has an A allele, you know that child had to get the A from mom. She had to pass on some kind of A allele. If the child has a B allele, can't get that from mom, or else mom would be AB, not even A. So that B allele had to come from baby daddy. So I know for a fact I'm going to give the father a B allele. But what his second allele is, it can be a B or it could be a BO. You would just have to tell me both because you have no other information to confirm what it is. You just know for a fact that the father has blood type B. That's his phenotype. What his genotype is, hetero or homozygous, you're not sure. Okay, let me give you one more. If mom is B, dad is AB, potential children are what? So how does the BO work? I'm confused about that one. Is it codominance? No, O is a true recessive. The only dominant alleles in blood are AB. O is actually recessive. So if you inherit an O, you have a real recessive allele. But if you inherit hetero AB, you are what we call codominant. Because A and B will show up on your blood with both proteins. So like A blood, think of it as like spikes. B blood has dots. So an AB has spikes and dots. Okay? Because blood type A has a certain kind of protein, B has a certain kind of protein, but when they both are inherited, they both show up. So it's codominant. So in this case, if mom's B, dad's AB, what possibility is the child? On this one, you would need to do the Punnett square. You would need to show me both possibilities for this mom because you can't confirm what the mom is. You don't know if mom's homo B or hetero BO. So if mom was homo B, then child has the possibility of being blood type B or AB. Now, if mom was BO, it doesn't really change things too much. I mean, well, it kind of does. Now the child has the possibility, if the mom is BO, the child has the possibility of being blood type A or blood type B, this time as a hetero. So on a question like this, you would just do the Punnett squares and show me what the child possibly can be. So up here you would say child could be AB or BB. Child could be AB, BB, BO, and AO. Again, this only happens because blood type is an example of a multiple allele, because you have 3 versions, right? You always inherit 2 copies of everything, but you can inherit 2 copies of 3 options instead of just 2. So on this last one, yeah, so the child can be A, B, or AB as far as their phenotype. Their genotype, they would be hetero A, AB, homo B, or hetero B. All right. Any other questions? Sorry, I got distracted watching Back to the Future 2 on the TV. All right. Anything else I could answer or go over? Look at your vocab. Make sure, like, just real quick, grab a partner or something at lunch if you have time or whatever, or before school, and just say, hey, tell me if I'm right, and describe the word codominant, incomplete, sex-linked, epistasis, right? Give an example, like, can you describe it? Can you define it? If you can define it and describe it, then you know the word, and then be able to give an example. Okay? Because I think y'all are better now at the Punnett square. I think you're better at doing that Punnett square and being able to, write out what the offspring are. But now you just need to know what they mean. If it's homo, hetero, codominant, incomplete, that kind of thing. All right. Any last minute questions? Give you a minute or two to type. If you're good, give me a good. I feel pretty good now. Thank you. Yep. Obviously, Gracie, you can just call me. Maybe I won't answer. All right. Okay. Jessica, if you're still on there, do you have any questions? No. Good. Okay. All right. Review as you need to. Click on the quizzes, right? Watch the, do the quizzes, watch the Bozeman video that's linked if you need to watch those. Okay? All right. So y'all will have a few minutes. I told her to give you a few minutes to study before she gives you the test. I have y'all spread out throughout the classroom. She has the actual seating chart on who goes where. Be sure to grab your dividers, right? Cover yourself up. Guys, don't forget to put your phones in the pockets. That would really suck to be caught with a sub and during a test. That's an automatic 0. I wonder who this could be calling me. Okay, so you want me to take the timer off? Okay. All right. Okay. They're called immunoglobulins. No, but that's just where the letter I comes from for the blood when you're doing the genotypes. You don't have to write it as letter I. You can just do it as A and B and AO and stuff. You don't have to put the I. Ooh, immunoglobulin. All right. Do you have any more questions? If not, I'm turning this off. Okay. What? I'll see. Okay. Love you. Bye. She was asking if I would post more practices for pedigrees and karyotypes. You can find the links on Classroom. Okay. Bye.